All right, so here we are with part 2, where we're just focusing on the systems of inequalities. Okay, if you want to see the first part, go to part 1 and see how to just graph one inequality. So now, instead of just one, now we're putting more than one here. Okay, notice that we've got more than one on here. And you should notice some aspects of the shading, okay, which we'll cover and we talk about these. Okay, first thing to notice, y is less than or equal to 2x minus 3. Okay, that equal to means a solid line. Okay, whereas not equal to is our dotted line. Not equal to means the line is not part of the answer, it's the boundary, whereas a solid line means the line is also part of our answer. Okay, so where would be a solution? Well, first let's start with the bottom. Where wouldn't be a solution? Well, there would be no solution where there's no shading. Okay, so 0.00 would be no solution. The point -4, 5, -5, -2. So basically anything within this zone right here is not a solution, not an answer. Okay. So then, okay, where would there be a solution to everything? Well, notice, okay, this dotted line is shaded right here. Okay, the dotted line is B, right? And the solid line is shaded right here. That's part A. So where would be only one for part A? Okay, well, it would be in this zone, right? So anywhere in this zone, so like 1, -4. Whereas for part B, the dotted line, it would have to be somewhere up here. So maybe like 2, 4. So that means the only place where where both are shaded is going to be this area. This is where the solutions are, because to be a solution of both the system, it's more than one inequality. So it's where they're shaded in here. So like 4, 0 would be one. So the way to think about this is there's 4 zones. Okay, there's the no solution zone, which we can see right here. Okay, there's the one solution zone here or here. Okay, and it's one solution for each different one, where it works for just one of them. And then there's the section that is where the solution to the system is. Okay, looks like that. All right, so where would be the solution to the system of equations in this one? Well, this part where they're both shaded, which would be right here. Now, it could also be on the line, so it could be any of those points too, because that's the solid line. It could not be that point. Okay, so I'm going to go with -5, 2. So the point where there'd be no solution for anything would be over here in this area, right? So let's go for -1. And there's multiple options here, right? Multiple options. Now, you couldn't put it on the line here, but you could actually put it on the line on that one. Okay, then part B, y is greater than or equal to 1. So y equals 1 would just be a solid line. So it's this solid line here. So it's anywhere on the line over here or up above. Okay, that would be a solution to just inequality A. So let's go 2, 3. Then for inequality B, would be from this zone and down, right? Any one of those. So we'll go 0, -4. Okay, and so when we're dealing with the system of inequalities, that's what we're looking for. We're looking where it overlaps, where the shading overlaps. All right, let's try some story problems. Okay, so Patty makes $8 per hour mowing lawns and $12 per hour babysitting. She wants to make at least $100 per week, but can work no more than 12 hours a week. Write and graph a system of linear inequalities, okay, and then list 2 possible combinations of hours that Patty could work at each job. So let's call this the mowing lawns and this the babysitting. So X is mowing lawns, Y is babysitting. So we know that she can only work for 12 hours a week. So if we took the hours, I guess this would be hours babysitting and hours mowing lawns, and we combined them with the hours mowing lawns, and I swapped those, didn't I? Okay, so they could be equal to 12 hours, but couldn't be over 12 hours. So it'd have to be less than or equal to. Okay, so remembering how to graph these, think, well, what if she only did babysitting? Okay, so if she only did babysitting, that would be finding the x-intercept, so it'd be like, well, the y was 0, so x would equal 12, right? And then what if she only did mowing the lawn? She could do a maximum of 12 hours. Okay, and because it could be equal to, so from 12 to 12, that represents mowing lawns. Now, she could mow, or that would represent 12 hours. She can work less than 12 hours, so we can shade below, right? And also the line would tell us exactly if it's 12 hours. Shading below would be less than 12. Now, in the story problem, it doesn't make sense to have negatives, so we need to kind of eliminate that part and just go to the zeros. Okay? Now, let's talk about the pay. Okay? So, she wants to make at least $100 per week. So she can make more than $100. So let's do it over here. It can be more than or equal to $100. But she wants at least. Now, for mowing lawns, okay, she gets $8 per hour. So it'd be 8 times the number of hours she mows lawns. She would add to that the $12 times the number of hours babysitting. Okay? So we'd get 12x plus 8y is greater than or equal to 100. Now again, we can say, well, what if she just babysits? So what if we eliminate the mowing lawns? So we'd have $12 an hour. So how many hours would it take to get to $100? Well, we'd go 100 divided by 12. That would give us 8.3. So she would have about 8.3 right about there. Okay? That's if she eliminated all of the lawn mowing. What if she only mowed the lawn and didn't do anything? Then we'd have just the 8y and we'd get rid of the 12x. So it'd be 100 divided by 8. And that would be about 12.5. So right up there. Again, we'd have a solid line here because that line represents all the possible combinations of hours of mowing lawns, and that would be $100. Okay? But also, she wants to go more than 100. So any point below would make her earn less. So all the points above, that's where we're shading for her. Okay? So we look at where they combine. And they combine in this zone right here. So I think that could be a point, or that a point, that a point. Those two could be points. Those right there, okay? So here are all the possibilities, and any, really on any of the line anywhere. Okay, so what possible things? Well, she could babysit for 11 hours and mow the lawn for 2 hours. Okay. She could also, maybe she wanted to mow more lawn, so she could mow lawn for 5 hours, right? And then she would work for 7 hours. She could babysit for 5 hours and then do 7 hours mowing the lawn. Okay, so those are two possibilities. There's a bunch as long as they find themselves within that zone. Okay? All right. So Jane is buying fruit salad and potato salad for a picnic. Fruit salad costs $2 per pound and potato salad costs $4 per pound. Jane needs to buy at least 6 pounds of salads and she doesn't want to spend more than $20. So let's do money first. So $20 is our max. So it's got to be less than, but it could be equal to. Okay, so the cost of fruit salad is $2, so it'd be 2 times x, because x is fruit salad. We'd add to that 4 for potato salad times y, the number of pounds. That would be one option. Okay. The other one is she's going to buy 6 pounds. Okay. So the x, pounds of fruit salad, plus the y, pounds of potato salad, is at least 6 pounds. So it can be bigger than 6 pounds, but it has to be at least. Okay. So the pound would be easy, right? Because if I only get fruit salad, it's going to be 6. If I only get potato salad, 6. So this is fruit salad, and this is potato salad. So I'd go 6 and 6, and then I'd graph that line, realizing that it can be more than that, so then I would shade above that. And all those points would represent more, right? Okay, then for the potato, or for the cost, okay, if I only bought fruit salad, that would be 2x is less than or equal to 20. Divide by 2, and we get x is less than or equal to 10. So it would be 10 up here. Then if I only bought potato salad, that would be like 4y is less than or equal to 20. So I could only buy 5 pounds of it. This would be right here. Okay, and then I connect the dots on that line. And then recognize that I can't spend more than 20, so below is where I shade. And then I look, where's the combinations? So it's going to be from this point to about there, okay? So what are two possible combinations? Well, we could buy 1 pound of fruit salad, right, and 7 pounds of potato salad. Or we could buy maybe 2 pounds, or maybe even 3. 3 and 3. I think that one would work. Or we could do 2 pounds and 5, or even 6. Right, I think that one would be in line too. So there's some possibilities there. Okay. So when we're graphing a system of inequalities, all we're simply doing is graphing both inequalities and finding where they overlap, and where they overlap, that's where our answer is. So let's jump right into it. If they're in slope-intercept form, it makes our life a lot easier, doesn't it? Okay, so -3 is our y-intercept. Slope of 1 over 3, up 1 to the right 3, or down 1 to the left 3. There's no equal to, so it's a dotted line, which means the line is not part of the answer. Y is less than, so most likely I'm shading below. Okay, it's easy when you're dealing with the slope-intercept form to just kind of see is it above or below. If I needed a test point, I could use 0, 0, and we would find that I might be wrong. Okay, because 1/3 times 0 is 0, 0 minus 3 is -3. Is 0 less than -3? Nope, which means it's not the answer. I was right. Okay, then the other one, +2, y-intercept of +2, slope of -4 over 3, okay, or up 4 to left 3. Again, no equal to, so again dotted, which means none of the lines are going to have solutions on them. Then I pick my test point, or think y is greater, so I think I'm actually going to go above. Okay, but let's double check it. 0 and 0, so 0 wouldn't be a solution again. Is 0 greater than 2? Nope, it's not. So there we go. So where's my solution? Well, red and blue make purple. So that right there is my solution, that purple area. Again, the solution is multiple points, all the points within that area. So we kind of think of it in terms of areas. +3. 5 means we go up 5 to the right 1, or down 5 to the left 1. There's no line, so it's a dotted line. Y is less than, so meaning I would probably shade down. Okay, if you need to, 0 is less than 5 times 0 plus 3. Is 0 less than 3? It is, so I was right. Okay, Second one, -1 for our y-intercept, slope of x, so that's 1 over 1, so it looks just like that. Or down 1 to the left one. It's got an equal to, so this one's a solid line, which means that could be part of my answer. Then y is greater, so I'm shading above. Okay, so then where are they overlapping? It's in that purple zone right there. So that's our solution. Okay, 23 plus 2, so we've got the plus 2, down 1 to the right 2, or up 1 to the left 2. It's got an equal to, so it's a solid line. Y is greater, so I'm going to shade above. Okay, then -1 here, and we're going up 1 over 1 because it's got a slope of 1. It's also got an equal to, so I know it's a solid line. Y is greater, so again I'm going to shade above. So my solution is from this line to this line and everywhere in between. Okay, now when it's not in slope-intercept form, a little trickier, but remember we think, well, what if I had no 4 or no x? Negative y is less than or equal to -3. Can't be a negative, so it'd be y is greater than or equal to +3. Okay, y is greater means I'm probably going to, y, not x. Probably going to shade that direction. Okay, then if we get rid of the -y, now 4x, before x is less than or equal to -3, so divide by 4, just +4. So x is less than or equal to -3 over 4. Okay, so that's like -0.75, so like right there. There's an equal to, and it's x is less than, so probably that direction. Put them together, and I'm probably shading this direction, aren't I? If I need to, use that test point of 0, 0. 4 times 0 would be 0, minus 0 would be, is 0 less than or equal to -3? Nope, 0, 0 would be right there, so we shade the opposite side. Okay, then the bottom one. So if I have 2x is less than or equal to -3, the x is less than or equal to -3/2, which is like -1.5. So -1.5 would be right about there. And x is less than, so I'm probably shading this direction. Okay, and then just y is less than or equal to -3, so at -3, y is less than, so probably shading that direction. It's also equal to, so we'd end up with that. Okay, so shading this direction. So again, where do they overlap? Right there to there, and everywhere beyond that. All right. 25 and 26, we're almost done. These ones take a while. That's why I say if you have some electronic way, like Desmos or in class, we're using our calculators, definitely utilize those. Okay, definitely utilize those. So I've got 3x is less than 2, and -2y is less than 2. So x is less than 2/3, which is like 0.6, so be like right there. And x is less, so probably to the left. Divide by -2, we get y is greater, because we've got to change the direction, than -1. So -1, shade that way. It's not equal to, so we're going to have to do dotted lines here. And then shade that way. For this one, we've got 3x is greater than -6, and -2y is greater than -6. If we divide by -2, we get y is less than +3. +3, less than is down. Divide by 3, and we get x is greater than -2. -2, greater is that way. It's also a dotted line, so we shade to the right. So the area that they're the same would be the middle area, wouldn't it? So that would be our solution. Okay, 26. So what I'm doing is just, when I write x is less than 6, pretending as if the y were 0. And then negative 3y is less than 6, pretending that the x were 0. Okay? So we get x is less than 6, so 6 would be right about there. And less than would go here. Negative 3y, we divide by negative 3, and we get y is greater than negative 2. Negative 2, probably shading that direction. No equal to, so dotted line, shaded above. Now, if you can't see how I'm using the inequalities to help me shade, then what you would do is pick a test point, so like 0, 0, and then plug 0 in for x, 0 in for y, and then we see if it's true. If it's true, that's the area you shade. If it's false, you shade the other one. Okay, then the second one, so if negative 3y were gone, we'd have 4x is less than or equal to negative 3. Divide by 4, x is less than or equal to negative 3/4, which would be negative 0.75, so like right there. And x is less than, so probably shading to the left of that dot. Then, if the y were there and the x were gone, negative 3y is less than or equal to negative 3, divide by negative 3. Get y, it's negative, so change the inequality to a 1. 1 as y is greater, it's equal to, so we draw our solid line, and we'd be shading this direction. Again, if I didn't know how to do that, I would just take this and plug in, like pick up test point, which 0, 0 is always my favorite. Go 4 times 0 minus 3 times 0, is that less than or equal to negative 3? 0 minus 0 is 0. Is 0 less than negative 3? Nope. So that's why we shaded the opposite side. But for our system, okay, we've got this area of the graph where it's overlapping and is our answer. Okay? Now, most of the time we deal with just 2, but it can be more than 2. Okay? So if that's the case, we're just going to graph all 3 of them. Okay? Okay, so here we go. So our first one, we've got 5x is greater than or equal to negative 10, right? If 2 didn't exist. And then if 5 didn't exist, it would be 2y is greater than or equal to negative 10. And this is the way I just find their x and y intercepts, by solving just for the x and just for the y. Okay, so we have negative 5. Then y is bigger, so the way that happens is by going this direction. Kind of helps me know how to shade too. X is greater than negative 2, so negative 2, and we're shading this way. So when I draw my line, I know which direction I'm shading, this way. Okay, then for the second one, I'd go 3x is less than or equal to 18, and negative 2y is less than or equal to 18. Just splitting it up as if they were, their parts were gone. So we get x is less than or equal to 6, and less than, so that direction. Divide by negative. Remember, when we divide by negative, our inequality changes. We get y is greater than or equal to negative 9. Now it's equal to again, so another solid line, and greater than and less than, so I'm shading this direction. Which if it were 2, that would be my answer right there. But we've got this third one now, don't we? So I'd go 3x is greater than or equal to 27. And negative 9y is greater than or equal to 27. Divide by negative 9, change my inequality. Y is less than or equal to negative 3. So negative 3, and I'm shading below. Divide by 3, and x is greater than or equal to 9. So at 9, I'm shading above. And it's also equal to, that wasn't a very good angled one. So it would go that direction, and I'm shading below. So where are all of them shaded? Well, there's this little triangle right here, isn't there? Wait, hold on. There we go. It can get kind of confusing to do it, so sometimes it's good not to sketch out all the shading, and I'll show you what I mean on the next one. So that purple triangle is my solution. So what is a point within that purple triangle? Okay, well, how about that point right there is 1. Positive 1, negative 4. Okay, all these points right in here, though, would also work. So there's quite a few points you could choose from. Okay? All right, last problem. Again, we graph them. So we've got 2x is less than or equal to 24. Negative 3y is less than or equal to 24. Oops, having trouble there. So y is greater than or equal to negative 8. And x is less than or equal to positive 12. So x, positive 12, would be out here. Y, negative 8, right here. Okay, it's a solid line, so we draw our solid line. And I would be shading x is less than, so that direction. Y is greater than, so that direction. Okay, so I'd be shading this direction. Okay, or I can write them on like that, give us an idea. Okay, then my second one. So x is less than or equal to 8, and 4y is less than or equal to 8. So y is less than or equal to 2. So 2. Y is less than, so shading that way. X is less than or equal to 8. Shading that way. It's also a solid line. Okay, so we'd be shading this direction, wouldn't we? Below. So I can see a joined area would be right here. But we've got that last one to do. So 3x is greater than negative 3, and y is greater than negative 3. So y is greater than negative 3 right here, shading up. Divide by 3, and x is greater than negative 1. So negative 1 greater would be shading this way. It's a dotted one because it's not equal to. So the line is not part of the answer. Okay, but I'd be shading in this direction. So I can see from the yellow line, I'd be shading here. From the red line, I'd be shading here. From the blue line, I would be shading right here. So our combined area would be within this triangle again. So then I would look and find where are some points here, right? Okay, any of those points in that area would all be solutions. So I can just pick one. Let's go 5, negative 2. That's my point, but any of these points in here you can choose from. And that's how we graph inequalities in systems. Okay? The whole point, again, is looking at that shading. Okay? So again, where everything is, both things are shaded or multiple things are shaded, that's our solution to the system. Okay? Where nothing is shaded, that's no solution. Where one of them is shaded, that's a partial solution, but only for one equation, not for both. So you can't consider it a solution to the systems. Only that area works. Okay? All right, so quite a long assignment here, but there you guys go. We are done, and hopefully the technology would make it a little bit quicker than by hand. All right.